Hi students, Assalamu alaikum students. Today we have to read about resistors in parallel. Lastly we read about the resistors in series, and they are said to be in resistors are said to be in series when they are connected end to end. But today we have shown a different picture, and this is called as a parallel combination of resistors. What happens? This is the one end of resistor, this is the another end of resistor. For the same one end, second end, for the third one and second end, another end. So resistors are said to be in parallel. Two or more than two resistors. We can have three, 400. How many resistors? A number of resistors are said to be connected in parallel if one end of each resistor. This is the one end. This is the one end of another resistor. This is the one end of another resistor. If one end of each resistor is connected to one common point, and another end of each resistor is connected to another common point, such that same potential difference, whatever is the voltage applied across the combination, same voltage across R1, R2 and R3. What here differs is current they are going to take according to their resistances. Here the current is divided into three parts. There is a simple difference between series and parallel. In series voltage gets divided, and in parallel current gets divided, because the voltage here is same. Whatever is the voltage for R1, same is for R2 and same is for R3, and they will take current according to their resistance. More resistance, less current; less resistance, more current. This is current I, and again this is current I. So resistors in parallel, two or more than two resistors are said to be connected in parallel if they are connected such that each end of one end of each resistor is connected to one common point, and another end of each resistor is connected to another common point, such that same current flows through them. Now here we can say, in order to derive this equation, we can have here I, the total current, equals to I1 plus I2 plus I3. But according to Ohm's law, we can have, but by Ohm's law, just name it equation first. By Ohm's law, we can have I1. I1 is the current in this very resistor. I1 equals to V by R1. I2 equals to V by R2, and I3 equals to V by R3. Now using these very values here, we will get I equals to, instead of I1 we will V by R1 plus V by R2 plus V by R3. But if we're going to see, if RP means the net equivalent resistance in parallel combination, RP is effective resistance in parallel. Then what we can write? We can write I, the total net current, equals to V over RP. That's equation. Therefore, instead of I, we will put it as equation second will become as V by RP equals to what? V by R1 plus V by R2 plus V by R3, which implies if V is going to take common from this side, then it is going to cancel with this. It will be simply 1 by RP equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance in case of parallel combination. Thus, in case of parallel combination, the sum of the reciprocals, this is the reciprocal of resistance R1, this is the reciprocal of resistance R2, this is the reciprocal of resistance R3. Thus, the sum of the reciprocals of separate resistances is equal to the reciprocal of, this is the reciprocal of equivalent resistance. Thus, the sum of, this is the sum of the reciprocals of separate resistances is equal to the reciprocal of equivalent resistance. This is the net equation. Now, in case of this very parallel combination, what we have to remember? We have to remember that we get a least resistive circuit. The net equivalent or the effective resistance is always lesser than the least one. If it is 2 ohm, it is 3 ohm, it is 0.5 ohm. So our equivalent resistance of this very combination will be less than 0.5 ohm. It will be less than 0.5 ohm. We have to remember this, that it will be less than the net equivalent resistance in the combination will be less than the. So now if what we are having, if we are having if we are having R1 equals to R2 equals to R3 equals to R. If we are having three resistance or n resistance and their resistance are equal, then 1 by Rp equals to 1 by R plus 1 by R plus 1 by R plus dash 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 plus 1 by R. If we are having n resistance, so it will be n by R is equal to 1 by Rp, R, which implies Rp equals to R by N. This is how we are going to find out effective resistance in parallel combination. Now there are some advantages and disadvantages in parallel and series. Now let me make the again the diagrams. This is the diagram in case of the series combination. Let me make the three resistors or two, yeah, whatsoever. This is V, this is positive, this is negative. This current I, here it will be R1, here it will be R2, here it will be R3. And if we are making here one another the parallel combination, one resistor, two resistor, and three. This is positive, this negative, this voltage V, this current I. This is again R1, this is R3, and this is R2. Here again the current will be I, but they will take currents. Here the voltage is V1, V2, V3, but here the voltage is same but currents are different. It will be I1, I2, and I3. Now from the diagrams, one of the what I mean to say advantages of parallel combination as compared to this very serious combination, that if one of the this is having a disadvantage as the same current flows through every appliance. That is why all the devices cannot work properly. Whatever is the requirement of current, same requirement cannot be for this very combination. And so there can be different requirements for different currents. If they are connected to different appliances, if they are connected in series, they drag the same current, then they cannot work properly. This is a disadvantage. On the other hand, they take currents according to their resistances, they work properly. That is why this very parallel combination is preferred. And moreover, if one of the appliances or devices or resistors break, if this breaks, yeah, this one breaks, or this one, the whole circuit will break. But if this one breaks, the two will work. Or if this one breaks, these two will work. Or if these two breaks, this will work. But in this, if one of breaks, the circuit will not work. So it is having more disadvantages rather than advantages, but it is having the advantages. This is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.